Hello and welcome to Maths Class.
Let's move to the reading and understanding of question number 3. Please don't go anywhere during the lesson, because if you are missing any part of the lesson, you will be missing important concepts. Okay, and for PTB students, this question can come in your long questions. So let's read and understand the question. Question 3 says, prove that the midpoint of the hypotenuse of the right angle triangle is equidistant from three vertices P, which is minus 2 and 5, Q 1 and 3, and R minus 1 and 0. Let's try to understand the question once again. What we have to prove, what we have to show, the midpoint of what? Hypotenuse. Of what type of triangle? Right triangle. Is equidistant. Equidistant means, okay, recall my previous lesson, that the distance of the midpoint of the hypotenuse is same from all three vertices. Now there are three concepts that we need to understand. First of all, we need to understand that which side is the hypotenuse among P to Q, Q to R, and R to P, and recall, students, what tells us about the hypotenuse and in what type of triangle we will have the hypotenuse. We need to prove this triangle a right angle triangle, and which technique tells us that is a right angle triangle. For that we should have the good command on what? Pythagoras theorem. First technique that we have to apply is the Pythagoras theorem, and the distance formula, then midpoint, and then again distance. I hope the format of the question is clear to you. So in order to prove that this triangle is a right angle triangle, what we have to do, first we have to find all three distances. So let's begin. Okay, so distance PQ, D1 be the distance. Let D1 be the distance PQ. P to Q distance is D1, and P has the coordinates. For every part I advise it to my students to write down the coordinates, minus 2 and 5, and Q has the coordinates 1 and 3. So let's go for the calculation of D1 equals to PQ, and recall the formula. Supporting our formula is really important. X2 minus X1 whole square plus Y2 minus Y1 whole square. If you want to secure good grades in your exam, okay, X2 minus X1 whole square, and that will give me 1 minus 3 square, minus 3 square. Okay, this is 1. Let me reshape this. Okay, whole square plus Y2 3 minus 5 whole square, and I have to keep these all values under the root. This will become 1 plus 3, which is equal to 4. Let me see. Okay, PQ 1 plus 2, X2 minus X1, this is 2. This is 2, sorry. 1 plus 2 whole square plus 3 minus 5. This is again minus 2 square, and under the root this is 3 square plus, recall my previous lesson, that the square of the number, whether that is negative or positive, what will that become? This will be 9 plus 4, which is equal to 13. And let me mark the number here. Now D2, we are done with P to Q. Then go in a sequence, D2, Q to R, Q to R distance, Q to R distance. So Q and R. Again, this time I'm not going to use formula, but while you will be working in your exam and in your practice work, you must have to write on the formula. -1 whole square plus 3 minus 5 whole square under the root this will give me -2 square plus minus 5 minus 3 is 5 minus 3 is your 2. Let me reconfirm the coordinates. PQ, Q and R. Q and R, this is -1 and 0 minus 3. This is 0 minus 3. 0 minus 3 and this will give me -3 square under root. And this is 4 plus 9. Which is equal to 13 square root 13, and this is the second point. And then what we have to do is we have got the answer of P to Q, Q to R and R to P. D3 PQ, QR, RP. R and P, R and P. R has the coordinates -1 and 0, -1 and 0, and these are the coordinates of R, and P has the coordinates -2 and 5. Now what I have to do, I have to take the difference, x2 minus x1, this is -2 minus -1 whole square plus 5 minus 0, 5 minus 0 whole square and square root. This will become minus multiplied by minus is positive 1 whole square plus 5 square and under root. Then this will become -1 square plus 5 square under root, and this will become 1 plus 25, which is equal to 26, square root 26, and let it be answer 3. Now do observe all the answers, students, carefully, that this is square root 13, this is square root 13, and this is square root 26. It means that if I'm taking PR from 1, 2 and 3, from 1, 2 and 3, PR distance, PR square equals to what? PQ square plus QR square, that is 26 square root, and I have to take the square of that, under root 13 and square of that, plus under root 13 square of that. Okay, 26 equals to 13 plus 13. So it means that PQR is a right triangle, with which side as the hypotenuse? With PR as hypotenuse, PR hypotenuse. Okay, now we have decided that which side is hypotenuse, and then the second requirement is the midpoint of the hypotenuse. So it means I have to find the midpoint of the hypotenuse. Just for the drawing purpose, I have to find the midpoint of PR. Now MXY, this time I'm not writing the formula. Okay, let me write, because the students will not be comfortable in this way. X1 plus X2 over 2 comma Y1 plus Y2 over 2. Of which side? PR side. -2 and -1, -2 -1 minus 2 minus 1 by 2 comma 5 plus 0 by 2, and this will give me minus 3 by 2 and 5 by 2. Now the second problem has solved. And the third problem, what is the third problem? The third problem is that the midpoint of the hypotenuse is equidistant from all three vertices. It means now we have to find out the distance P to M, then M to R and M to Q, and we have to see whether all the distances are coming same or not. So now PM distance, recall the distance formula. For this topic it's really important to have understanding of all the formulas. PM distance will be equal to PM x2 minus x1 whole square minus 2 minus 3 by 2 and whole square plus y2 5 by 2 minus 5 by 2 minus 5 whole square PM. Now minus multiplied by minus will become plus. This will become minus 2 plus 3 by 2 whole square plus 5 by 2 minus 5 whole square. Now in order to solve this I have to take the LCM. So 2 will be the LCM here, minus 4 plus 3 whole square plus, again 2 is the denominator, 5 minus 10. 2 times 5 is 10 by 2 whole square, and then this will become minus 1 by 2 square plus 5 minus 10 is minus 5 by 2 square, and this is I have to put the square root as well. Let me see whether my working is coming in camera. 1 by 4 plus 25 by 4, and this will give me 4, and 1 plus 25 is 26 by 4. 26 by 4. Either I can leave my working at this stage, or what we can do is that 26 by 2 and let it be 1. 26 by 2, and then what I have to do is I have to find the second distance. The next distance is M to Q. M to Q distance will be equal to x2 minus x1. x2 minus x1 minus 1 minus 3 by 2 whole square plus y2 minus y1 0 minus 5 by 2 QM. Sorry, I am writing QM, so I have to be careful. 1 minus 3 by 2 and 3 minus 5 by 2. 3 minus 5 by 2. Let me do it again. 1 minus 3 by 2, students, and 3 minus 5 by 2 whole square. Okay. Then this will become positive. This is 1 minus 1 plus 3 by 2 whole square, and let me write this portion as it is. So I will be solving this in the next part in order to give symmetry to the working. Now take the LCM here. 2 minus 2 plus 3 whole square plus 6 minus 5. 6 minus 5 whole square. Let me recheck the coordinates. M has the coordinates minus 3 by 2, and Q has the coordinate positive 1. Positive 1 here, positive 1 here, and positive 1 here, and then y2 minus y1, this is 3 minus y by 2. Yes, this will become 6 minus 5 by 2 whole square under the root. This will become 5 by 2 whole square plus 1 by 2 whole square under the root. 5 square is 25 by 4 plus 1 by 4. 25 plus 1. 25 plus 1 will give me 25 plus 1 by 4, which is equal to 26 by 4. Either I can leave my working at this stage, or I have to write it in the same way like I've written the first part. And now I have to go for the third distance, which distance I have done. P to M distance is done, M to Q distance is done, and now we have to go for M to R distance. M to R distance, MR distance will be equal to what? X2 minus X1 whole square, and that is minus 1 minus 3 by 2 whole square plus y2 minus y1 0 minus 5 by 2 whole square. This one, let me see. I have put the bracket. This is the big bracket that I have to put, that tells us that we are taking the square of all the numbers. And then this will become positive minus 1 plus 3 by 2 whole square, and 0 minus 5 by 2 is minus 5 by 2 square. I have to take the LCM. 2 is the LCM. Minus 2 plus 3 whole square by minus 5 by 2 square. This will give me 1 by 2 whole square. That is 1. Okay, let me do this step. Okay, and this is minus 5 by 2 whole square, and under the root 1 by 4. Every time we are getting the same calculations. 25 by 4. 1 plus 25 is 26 by 4, or 26 by 2. So what are you observing from 1, 2 and 3? We can see that from 1, 2 and 3 we are getting all the distances same, because let me use different pen, because P to M equals to what? M to Q equals to P to M equals to M to Q equals to M to R equals to 26 square root 26 by 2. So from 1, 2 and 3, from 1, 2 and 3, hence proved. I hope you are really clear that how we are proving that the midpoint of the hypotenuse of the right angle triangle is equidistant from all of its 3 vertices. One of the important questions, long questions of your PTB examination. Please watch and understand this lesson for better understanding of the next lesson. Please watch my lessons, like, share and subscribe the channel, and press bell icon to get the notification of every lesson in time. Thank you very much.